Hi Dan, just a recap video, just going to run through what we did rather than write it all out again, especially those large multiplications. So just a quick, we did a recap of the multiplication technique. So we've got 2-digit method here, that's no problem for you. 3-digit method here, but that's usually no problem for you. Just made a slight error there, didn't you? And then here, obviously this is a bit more challenging, but with practice you become fluent at adding the four numbers together in the middle. Then I talked about how that one principle gets used in lots of places because you asked me, is fluency important? And the method itself contains enough fluency, enough practice in it because you're going to do that same technique again. That's the whole idea of the method. So to demonstrate that, I showed you straight away that you could do algebra. Why you can do algebra? Well, because you know how to multiply two numbers together. So you can multiply two numbers together, just that one of them you don't know what it is yet. You did that yourself, x squared plus 3x plus 2, and then I showed you that if x was 10, this would be 11 and 12, and this would generate 132, and that arrow is saying if x was 10, that's 100 plus 30 plus 2, which is the same thing. So it reveals to us that algebra is arithmetic, or arithmetic is algebra. That's the secret to it. That's never revealed at school. You said, you said you think this is a square because there's a square in it. Oh, sorry, it's a rectangle because there is a square in it, but there's these extra bits which are making it not square. And I pointed out that this was a square number, and why was it? And your answer that you gave me is very good, but I'd say it's only half the answer. So have another little think about why this is a square number. Look at the numbers themselves. Maybe that's a hint. So this will be the shape of a square. I don't think I mentioned it, but that's why it's called a quadratic, because it forms a quadrilateral shape, i.e. a rectangle or a square. Okay, then we use the same principle of multiplication as addition to look at, let's skip one, to look at indices. So here we looked at numbers first, we multiplied the powers, we multiplied these two things, which adds the powers, and we talked about why that was, because in total there's 5 of them. And then I said algebraically it's the same thing, because algebra is arithmetic, so it'd just be the same. Then some simple examples. I wanted to kind of lead you into the previous page. So t by t is t squared, because of 1 plus 1 is 2. Here we can think of that as 3 times 5 is 15 and 1 plus 1 is 2. Or just change the order. So 3 times 5 times t will give you 15t squared. And that took us back then to here. Remember I said, have you ever seen this one before? 3m times 5m, so 15m squared. And I think you said, oh yeah, that's finding the area. And that was the big reveal that indices and algebra does seem like fairly abstract, but actually it's something that you've been doing for a long time. And so you have that feeling of, oh yeah, I've been doing that since about the age of 8. So if I can do that when I'm 8, I can do algebra now when I'm far older. And that's it. So we did a lot of talk in between about educational theory, so that was all the maths we covered. So I hope that's okay, and look forward to speaking to you next week.